So we've got lesson 6, lesson 7, and that's it. 2 more days. So we'll be done this tomorrow. I'll give you guys your review tomorrow so you can start working on it. And we'll have our exam on Tuesday on antiderivatives. And then after that, it'll be review for the final exams. The final exams will be in class. There's 2 parts, part A and part B. Part A is mostly derivatives, part B is mostly integration, but I'll give you more information on specifically what the 2 parts will entail. And I'll also pick those 2 days. I think our last day of classes is the 15th, I think. So we'll probably be looking at the 13th and 14th for the exam. Final exam. Yep.
We're getting near the end here.
Yeah. Also remember, June 9th, last day to hand in any missed assignments. So you want to get cracking on that stuff. Don't leave it till the end. All right, so we saw the fundamental theorem of calculus, what it is. If f is a continuous function over an interval from a to b, then the antiderivative or the definite integral from a to b of f at x can be found by taking the antiderivative and evaluating for b minus the antiderivative and evaluating for a, where capital F again is the antiderivative. So just some more practice with finding definite integrals. So we'll look at a couple of these straightforward ones, and then we'll also get into some involving trig functions as well. And then also we'll talk a little bit about or do another more examples with that substitution rule. But we don't need that for question 1. Remember, substitution rule is usually only used if you have a product or a quotient that can't be simplified. But these first few ones are not like that, so we can go straight into finding the antiderivative by adding 1 to the power and dividing by that number. So it'll be 1/4 x to the 4th that we'll evaluate from -1 to 2. So again, the question was asked yesterday, what about the c's? And I showed you guys when we first started looking at evaluating these definite integrals that when you subtract the 2 antiderivatives, the c's cancel. So you don't need to worry about those. Pardon me?
The c's cancel for this one too.
They all do. Because
because you're taking one at -1 and 1
yep. So the first one would be 2 to the 4th is 16 times 1/4 is 4 plus c minus when x is -1 in brackets plus c. The c's will cancel. Thank you for acknowledging that I'm right. And so I guess we don't need to put a at x there because we're not really talking about area here. We're just evaluating the definite integral. So that will be found by letting x equal 2 and subtracting the value when x equals -1. So 2 to the 4th is 16. 1/4 of that is 4 minus -1 to the 4th is +1 times 1/4. So 4 would be 16 quarters minus 1/4 is 15 quarters. So there's the value of that one. Number 2. Again, we'll find the antiderivative. It'll be 3x minus 2/3 x cubed that we'll evaluate from -2 to 4. So we first find out what the value of this is when x equals 4. So it'll be 3 times 4 minus 2/3 times 4 cubed. And we subtract the value when x is -2. So you'll get 12. Now 4 cubed is 64 times 2 is 128 over 3 minus 3 times negative 2 is negative 6. Negative 2 cubed is negative 8 times negative 2/3 would be positive 16/3. The minus in front of the bracket changes all the signs inside. And we don't really need a bracket there. That'll be a plus 6 and a minus 16/3. So 12 and 6 is 18. Negative 24, negative 124, minus 16 will be minus 140 over 3. Let me just check that again. So that'll be a plus 6 and a minus 16/3. So 18, negative 124. Yeah, is. So then you would have to oh, 128, right. So that will change this. So that'll be minus 144 over 3, which you can divide those. 144 is divisible by 3. So it's 18 minus 48. So the answer is negative 30. So remember, we're not talking about area here. So it doesn't matter that it's negative. And also remember, we saw yesterday that we can use our graphing calculator if you're doing an assignment just to check. Right? So our original expression is 3 minus 2x squared. Put it in there, and then second function trace. We're going to do number 7, which is the definite integral. Our lower limit here will be negative 2. Our upper limit is positive 4. And it gives us the answer. And also shows it graphically, the area too. Okay? Even though we're not really doing area here, we're just finding the definite integral, but you can use the calculator to check all your answers. So looking at number 3, and I mean that really is, yeah, let's do this one. I would start by taking that second term and writing it as a power, x to the negative 2 on top. So we'll take the definite integral from 0 to 3 of 3 minus 2x to the negative 2. And now we'll take the antiderivative of that. So it'll be 3x. Now when you add 1 to negative 2, you'll get negative 1. And when you divide by negative 1, you're going to get positive 2x to the negative 1 that we're going to evaluate from 0 to 3. Or 3x plus 2 over x that we'll evaluate from 0 to 3. Now, this one cannot be done because 0 is a non-permissive value. And because the lower limit is 0, can't do it. There is no solution to this one. 0 is a non-permissible value. Let's see. So y equals 3 minus 2 over x squared. So second function trace, number 7. The lower limit is 0. The upper limit is 3. Get an error. All right. For question 4, I would simplify the expression first. We're going to go from -2 to 1. I'll divide both terms on top by the x to the 4th on the bottom. So that'll be 1 over x squared plus 4 over x to the 4th, or the definite integral from -2 to 1 of x to the -2 plus 4x to the -4, and this is what I'll take the antiderivative of. So x to the -2, and we take the antiderivative of that term, we add 1 to the -2 to get -1. That'll be the new power. We'll also divide by -1, so you'll get -x to the -1. When you add 1 onto -4, you'll get -3, so it'll be -4/3 x to the -3. That will evaluate between -2 and 1. Or -1 over x minus 4 over 3x cubed, that we evaluate between -2 and +1. So first, when x is 1, we're going to get -1 over 1 minus 4 over 3 minus, when x is -2, -1 divided by -2 is +1/2. And this next term is going to be positive as well, because on the bottom, when you do -2 cubed, you're going to get -8 times 3 is -24, but the minus minus will make it a plus positive. It'll be 4 over 24, or 1 over 6. So to add these together, our common denominator will be 6. So -1 over 1 will be -6 over 6, minus 8 over 6, minus 3 over 6, minus 1 over 6. So -6, take away 8 is -14, -17, -18 over 6, which is -3. So there's the value of that definite integral. And again, we can check that. We'll go to y equals, we'll put the expression in, the original one, using brackets to keep the numerator together, x squared plus 4, in brackets, all divided by x to the 4th. And then second function trace, number 7. Our lower limit is -2. Our upper limit is +1. So it says an error, and here's the reason why. Because within that interval from -2 to 1, you're going to have 0. And this graph is cannot evaluate it continuously between -2 and 1, because 0 is a non-permissive value. Even if you simplify it, 0 is non-permissive value. So in reality, even though we do all the work and we get an answer, there is no solution. There is no solution, and the reason is because 0 is a non-permissive value. How do you know? Well, because if you take the antiderivative has denominators of x. And so when you have a denominator of x, 0 is a non-permissive value. And the reason this doesn't work is because 0 is within the interval that we're asked to evaluate for. Had we gone from, let's say, +1 to +5, that would work, because it doesn't include 0. So in this case here, you wouldn't have to do all the work. You would just find the antiderivative and then look back at what the interval is. And if you recognize that a non-permissive value is within the interval that you want to evaluate for, there's no answer. So, all right, number 5. The antiderivative of sine x is negative cos x. That will evaluate from pi to 2 pi. So that will be negative cos of 2 pi minus negative cos of pi. 2 pi's coterminal was 0. At 0, the coordinates are 1, 0. The cosine of 2 pi is 1, but the negative sign in front makes it -1. The minus becomes a plus positive. And then the cosine of pi, well, at pi, the coordinates are -1, 0. The cosine is -1 as well. So you're going to get -1 plus -1, which is -2. And again, we could check this on the calculator. You put the original expression, sine of x, in there. And then second function trace, number 7. The lower limit is pi. So I'm going to put pi in there. And the upper limit is 2 pi. And you see the answer, -2, is there. Okay? So once again, we've got our tables of indefinite integrals that are on the formula sheet for you. We saw before that sine of x dx, the antiderivative of that is negative cos x. The antiderivative of cosine is sine. There's a couple more that are added in here. If you have the sine of ax dx and you want to take the integral of that, it's -1 over a cos ax. And same thing with cosine x. Okay, as well as some other ones there. Also remember the properties of integrals. They're similar to the properties of derivatives. C is a constant here. There is no x attached to it. It's a constant, so it can come in front. Right? And the fact that if you take the integral of the sum of two functions, it's the same as the individual integrals added together. This next one says determine the general antiderivative for that expression. So general meaning you're going to involve C because you're not given the interval. So it's going to be a general expression. So the antiderivative of the first term, you add 1 to the 2 to get 3, and you'll divide by 3. That'll give you 2x cubed. And the antiderivative of cosec squared x, if we look above, is negative cotan x. So it'll be minus cotan x plus c. There's that general antiderivative. Okay, I'm going to skip this one here. Let's go down to the second one. What I would do first here is I would change the radical to a power and then move it up to the top. That would be the same as x to the -2/3 that we're going to evaluate from 1 to 8. Now we'll take the antiderivative. By adding 1 here, you're going to add 3/3. And when you add 3/3 to that, you're going to get 1/3. So it'll be x to the 1/3, and we also divide by that value. And dividing by 1/3 is the same as multiplying by 3. So this would be equal to 3x to the 1/3 that we'll evaluate from 1 to 8. So when x is 8, you'll have 3 times 8 to the 1/3 minus when x is 1. And remember that power 1/3 means cube root. The cube root of 8 is 2 times 3 is 6 minus the cube root of 1 is 1 times 3. 6 minus 3 is 3. Again, we can check this on the calculator. We'll put the original expression in there. 1 divided by the cube root of x squared. There's our original expression. Go into the calculate mode, choose number 7. Our lower limit is 1. Our upper limit is 8. And it gives us the answer of 3. Had our interval included 0, there would not be an answer because 0 is a non-permissive value. All right, so for this next one, if we look back at our table of general antiderivatives, the antiderivative of sec squared x is tan x. Right there. So this will be found by taking the tan of x between pi on 6 and 3 pi on 4. So that'll be the tan of 3 pi on 4 minus the tan of pi on 6. If you look on the unit circle at 3 pi on 4, the tangent there is -1. That's in the second quadrant. And whenever you have the multiple of pi on 4, the sine and cos are the same. They're both root 2 over 2. So when you divide them, you'll get 1. But because you're in the second quadrant, that's our S quadrant, tangent is negative. Minus the tangent of pi on 6 is root 3 over 3. So if I write 1 as 3 over 3, it'll be -3 minus root 3 all over 3. So again, you can use a calculator to check this. We'll have to go 1 divided by, in brackets, the tan of x, close both brackets, and squared. I'm sorry, not tangent. The reciprocal of secant is cosine. There we go. So second function trace, number 7. Our lower limit here is pi on 6. Our upper limit is 3 pi on 4. We're going to get an error here because there is a vertical asymptote in between that interval. Yep. So yeah, I mean, just to confirm, if you go into trace mode, and if you put pi on 2 in there, there is no y value returned. X equals pi on 2 is a non-permissive value. All right, this last one we have to do by method of substitution. We can't simplify. So remember how that works. We let u equal the more complicated expression, which in this case would be x squared plus 1. Then du by dx will equal 2x. And we have that derivative statement. dy by du equals dy by dx divided by du by dx. So dy by dx is the original expression, except instead of writing x squared plus 1 inside the brackets, that's what u equals. So it'll be u cubed. And that is divided by du by dx, which is 2x. So dividing by 2x is the same as multiplying by the reciprocal, 1 over 2x. So if we look at it like that, the 2x's cancel. And you're left with 1 over u cubed, or u to the negative 3. That's what we'll take the antiderivative of. If we add 1 to the negative 3, we'll get negative 2, which we also have to divide by. So it becomes negative 1 over 2 u to the negative 2, or negative 1 over 2u squared. And then what we've usually done is we have put the x squared plus 1 in there for u, and then evaluated it from 0 to 3. But you actually don't have to do that. You can leave it in terms of u. But what you need to do then is you need to find out what u equals when x equals 0 and x equals 3. That's your lower and upper limits. And you can do that by using the fact that u is x squared plus 1. So our upper limit when x is 3, again knowing that u is x squared plus 1, our upper limit in terms of u would be 10. Our lower limit would be found by letting x equal 0. So it'll be 0 squared plus 1. So there's our lower limit in terms of u. So again, we can keep this expression in terms of u, but now we have to do it from u equal 1 to u equal 10. So negative 1 over 2 times 10 squared. Pardon me? I know, but we wrote it in terms of u, so that you don't have to put the x squared plus 1 in for u down here. So you'll get the same answer. But this maybe is a little bit simpler to work with, but you don't have to. So 10 squared is 100 times 2 is 200, so negative 1 over 200 minus 1/2. So our common denominator there will be 200. It'll be negative 1 minus 100. Let me just check this. So negative 1 over 2u squared. That's negative 101 over 200. Oh, I'm sorry. It's minus minus. So there should be a plus. There's a subtraction there originally, and the original expression is negative as well. So that should be minus minus. So that'll give us 99 over 200. (99 over 200), which again we can check. First, let's find out what 99 over 200 is as a decimal, just in case the calculator gives us that, 0.495. So when we put our original expression in there, I'll have 2x divided by, in brackets, to keep my denominator together, x squared plus 1. Whoa, what happened there? Plus 1, close the bracket, and that's cubed. Try it again. X squared plus 1 to the power 3. Second function trace, number 7 for integral. We're going to find it from 0 to 3, and we get the 0.495 that we got doing it manually. And this is what it's all about.
Is this x defined? Is f continuous? How do you find out? You can use the limit process. Approach from both sides, the left and the right, and me. I'm just a limit. My analytic function's continuous. There's no holes, no sharp points or asymptotes. Any way this graph goes, it is differentiable for me. All year in calculus, we've learned so many things about which we are gonna sing. We can find derivatives and integrals, and the area enclosed between two curves. Why prime is the derivative of y. Y equals x to the n dy dx equals n times x to the n minus 1. Other applications of derivatives apply if y's divided or multiplied. You use the quotient and particles, and don't you forget to do the dance. Also, get the chain rule before you are done. You gotta remember to multiply by the chain. I need to find the area under a curve. Integrate, integrate, you can can you see integration? Raise the sun and high one, multiply the reciprocal. At a constant label T. I'm just a constant, nobody loves me. He's just a constant, might as well just call it C. Never forget to add the constant C. Can you find the area between F and G? Integrate F and then integrate G and subtract. To revolve around the y-axis. Integrate. Consider radius square. Multiply by pi. Multiply the integral by pi. It tastes real good with whipped cream. Oh, mamma mia, mamma mia. Mamma mia, let me go. Pre-calculus did not help me prepare for calculus. For calculus, help me. So you think you can find out the limit of y? So you think you'll find zero and have it to find? Oh, baby, can't you find that point, baby? It's undefined, goes to positive and negative infinity. Differentiation, anyone can see. Any mere equation, it is differential for me. Any way this graph goes.
That was fun. Yeah. I think we did the whole thing. It's like, oh.
How to kill all mosquitoes in the area in 90 seconds.
Yes. And the light was What heck to watch? Just don't remember to save that link. But add that to my Spotify thing. For being high school students, yeah. I wonder if they just did that out of fun or like it was a project. Well, you don't know. They might have. I don't doubt they wouldn't.
Okay, so this one I'm gonna take in for marks.
Right. I'll write that down. Say no. What did you lose remarks to?
Yesterday's wasn't.
It wasn't.
No.
I just
Or did I say yesterday's?
Yeah, I think you said yesterday.
Okay, then yesterday's and not this one.
Okay.